Hi, welcome to Algebra 2. My name is Lily. This semester we studied 5 units: exponent functions, function families, polynomial functions, trig functions, and probability. At this exhibition, we will show you some of the real-life problems that are solved using algebra. Things like designing roller coasters, determining weather patterns, understanding submarine radar information, calculating the odds of winning at the slots, and creating graphic designs. Function families. I used the basic shape of a parabola and what I knew about function families to create a graphic design. The general equation of a parabola is x squared. It is graphed here using Desmos online. By adding a fraction in front of the equation, I can horizontally stretch the graph, otherwise known as a vertical compression. This is because the y value for any given x value is now a fraction of what it was before, lowering it on the y-axis and flattening the graph. Here I have added 1.5, 1/4, 1/8, and so on, changing the shape of the graph and not its location. Each graph gets wider and wider. By adding a whole number in front of the equation, I can vertically stretch the graph, otherwise known as a horizontal compression. This is because the y value for any given x value is now a multiple of what it was before, 2 times, 4 times, 8 times more, rising it on the y-axis and making the graph skinnier and skinnier. When I put both horizontally stretched and horizontally compressed graphs together, I get a flower. Graphic designers use mathematical equations to create images. Next, my classmate Amaya will discuss polynomial functions.
Roller coasters are based off polynomial functions. This is the King Dot Rock roller coaster at Six Flags in New Jersey. Designers use polynomial functions to build it. It reaches a top speed of 128 miles per hour. It's only a 50-second ride, and it travels over 3,000 feet. A polynomial function is a function with no negative exponents and no variables in the denominator. The degree of polynomial is simply the highest exponent. The degree minus 1 determines the number of changes in the direction or turns of the graph or the roller coaster takes. Roots are called zeros, and they are where the graph crosses or bounces off the x-axis. When building a roller coaster, it is important to know the end behavior of the graph the roller coaster is based on. The highest exponent is odd. If the highest exponent is odd, the ends of the graph go in opposite directions. If the leading coefficient or the number in front of the term with the highest exponent is negative, the right side goes down and the left side goes up, as seen on the graph on the right. If the leading coefficient is positive, it's the opposite, as seen on the graph on the left. If the highest exponent is even, both ends go in the same directions. If the leading coefficient is positive, both go up, as seen in the red graph on the left. If the leading coefficient is negative, both go down, as seen on the blue graph on the right. Now my classmate Selena will now discuss trigonomic functions.
Trig functions have many real-world applications, like waves of GPS and cell phones, TV and radio waves for transmission, and radar used to monitor things underwater. In this problem, the distance from K to the submarine is found using the Pythagorean theorem, and the measure of theta could be found using the inverse cosine. X is the distance from K to the submarine, and here X equals 346 and a fourth of a meter. Pythagorean theorem states that the sum of the squares of the length of the two legs of a right triangle is equal to the square of the length of the hypotenuse. Here, the cosine of an acute angle of a right triangle is equal to the adjacent side over the hypotenuse. If you know that value, you can use the inverse cosine function to find the degree of the acute angle. Next, my classmate Aaliyah will discuss probability.
Probability was our last unit. In this unit, we solved real-world problems like this one. What is the probability of pulling 3 lemons on a slot machine? How much money will you win or lose if you bet 100 on each pull in the pull slot machine 1,000 times? Payout is 900 coins, totaling $90,000. How can we use this information to calculate player payout in House Edge? To calculate the chances of pulling 3 lemons, we need to calculate the chances of pulling a lemon on each reel and multiply them together. There are 10 images on each reel. The probability of getting a lemon on the first reel is 1 out of 10. The probability of getting a lemon on the second reel is 1 out of 10, and the same for the third reel. The probability of getting all 3 requires you to multiply the individual probabilities. 1 out of 10 times 1 out of 10 times 1 out of 10 equals 1 out of 1,000. This means that out of 1,000 tries, only 1 try will get you 3 lemons. Translated into odds, it is written 999 to 1. When we worked out this problem, we learned that on average, a player loses 10% out of what he bets, and the house only returns 90% of what a player bets on any given pull of a slot. Multiply that by millions of slot machine players, and you can see why casinos make money and gamblers lose it. Thank you for listening to our presentation.